Hey guys, today we are going to be looking at finding the compound probability of an event. So let's go ahead and start off with some vocabulary. First of all, your title is compound probability. Your essential question is how can you find the number of possible outcomes of one or more events, and there's two ways. You can do this by the sample space or by the fundamental counting space. And we'll talk about those. But remembering compound probability means two or more events. So yesterday you looked at when you were undoing a lock, how many choices you have for those three numbers, okay? So your locker has a compound probability because you spin your numbers 3 times. All right, so go ahead and write these down, and don't worry, we will go over them. Example 1. We are going to be looking at, we are going to be looking at randomly choosing a style, a crust, and a style of pizza. Find the sample space. You can list the sample space, or you can use a tree diagram to find that sample space. So I prefer the tree diagram, okay? Our first event, remember, compound probability is made out of events. The first event is crust. The second event is style, okay? So first event, finding the sample space. You can use tree diagram, or you can just list. I'm going to use a tree. Crust. We have thin, or we have stuffed. First event. Second event, we have Hawaiian, Mexican, pepperoni, veggie. Hawaiian, Mexican, pepperoni, veggie. Second event. That second part of your tree is that second event. Done. Okay, find the sample space. Here's the sample space. How many different pizzas are possible? 1, 2, 3, 4, 5, 6, 7, 8. 8 possible. Just counting that sample space. Okay. Now, let's look at what if they add a deep dish. What's going to happen to our tree diagram is that we would also have in our first event, we would have a deep dish. And from the deep dish, we would still have that second event of Hawaiian, Mexican, pepperoni, and veggie. Now, how many possible outcomes are there? There are 8, 9, 10, 11, 12. 12 possible. All right. What is the probability of choosing a stuffed crust Hawaiian pizza? 1 stuffed crust Hawaiian, 1 out of, we're going to go back to that original and we're going to forget this what if, 8. 1 out of 8, which is, we do like to put that into percentages. 1 divided by 8 is 12.5%. There we go. So here's how you write the sample space, okay? Let's talk about an easier way of writing the sample space than having to list everything out. Or total outcomes. Find the total number of possible outcomes of rolling a number cube and flipping a coin. This is where we're going to use this fundamental counting space. It's just for total outcomes, total number. When we were looking at example 1, it asked us what was a sample space, so we had to list them. In example 2, it's just asking what's that total, okay? So it goes event 1 times event 2. because there's only two things going on here. If there was an event 3, we would multiply by event 3. If there was an event 4, we would also multiply by event 4. Okay, so event 1, how many outcomes does event 1 have? Rolling a cube has 6 sides, so 6 possible, times flipping a coin has 2 sides, 2. The total number is 12 possible outcomes, because event 1 has 6 choices, event 2 has 2 choices. All right, what is the probability of rolling a number greater than 4 and flipping tails? So, probability of greater than 4 and flipping tails. Equals, what are the total number of possible outcomes? 12. Okay, how many ways can you get a 4? And how many ways can you flip tails? We almost need a picture for this of our sample space, okay? Or we need to remember that multiply. So, and multiply. But let's draw our picture. So what is the probability of rolling a number greater than 4? Here's all of our possibilities for our first event. 1, 2, 3, 4, 5, 6. Here's all our possibilities of the second event. Heads, tails. Heads, tails. Heads, tails. Heads, tails. Heads, tails. Heads, tails. All right, a number greater than 4 happens twice, and flipping tails happens 1, 2. So 2 out of 12. Or, which reduces down to 1/6, which is in percent. 1 divided by 6 is 16.6%. Okay, or our first event is getting a number greater than 4 happens twice, times our second event of flipping a tails only happens one way, and 2 times 1 is 2 over 12. So this was your sample space, and this was that fundamental counting sample. I think sample is what it is now. Okay, so there's your 2 options for solving. What is the probability of rolling at most a 4 and flipping a heads? Let's look at this using that fundamental counting space. So probability of rolling at most 4 and flipping heads. So we have 2 events. Event 1, rolling at most a 4, happens 1, 2, 3, 4 ways. Okay, 4 ways. Event 2 happens flipping a head 1 way out of 12 total. Okay, so 4 times 1 is 4. 4 divided by 12 reduces down to 1/3, and 1 divided by 3 is 33.3 repeating percent chance. Okay, let's fundamental counting, sample space. Let's double check. Rolling at most 4 happens 1, 2, 3, 4. 4 ways here, and then we're going to look for heads in those. 1, 2, 3, 4. 4 out of 12 total. Okay. Depends on which way you want to approach these problems, if you're going to use that fundamental counting, which makes it quick and easy, or if you're going to draw the sample space and count from there. All right, example 3. How many different outfits can you make from the t-shirt, jeans, and shoes in the closet? We don't care about the sample space. We just want to know how many we have total. We're going to use that fundamental counting space. So, how many outcomes do we have? First of all, how many events? We have 1, 4, nope, those are, what are those? I think those are the jeans. Jeans, shirts, and shoes. So we have 3 events because there's 3 articles of clothing. So event 1 times event 2 times event 3 is how we find the total. Event 1 has 2 options times event 2 has 1, 2, 3, 4, 5, 6, 7 options, and event 3 has 1, 2, 3 options. Multiplying it to find the total, 2 times 7 is 14, and 14 times 3 is 42. 42 total options, outfits. All right, just because it was asking for us to know how many options do we have. All right, example 4. You roll a number cube. What is the probability of rolling double 3s? Oh, sorry, 2 number cubes. This one, we're not looking for a total. We're looking for a sample space here, so I'm going to draw a picture. So 2 number cubes, 2 events. First cube, second cube. First cube has 1, 2, 3, 4, 5, 6 possible. Second number cube has 1, 2, 3, 4, 5, 6. We're looking for double 3s. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You see how this gets tedious and why the fundamental counting space is very helpful. Okay, so double 3s only happens right here. So 1 out of 6, 12, 18, 24, 30, 36, which is the probability of 1 divided by 36 is 0.027 repeating, which is 2.7 repeating % chance. Very slim. Example 5. You flip a nickel 3 times, so 3 events, a nickel 3 times. What is the probability of flipping 2 heads? Let's use that fundamental versus our space. Probability of 2 heads. 2 heads. Oh, and 1 tail. Equals event 1 times event 2 times event 3, because we do this 3 times over total outcomes. All right. Flipping a head can only happen 1 time. Flipping a head can only happen 1 time. Flipping a tail can only happen 1 time. Over 2 possible outcomes for event 1, 2 possible outcomes for event 2, times 2 possible outcomes for event 3. The probability is 1. 2 times 2 is 4. 4 times 2 is 8. 1/8, which is, in percents, going to be 12.5%. All right, we're going to skip this last part and go to that essential question and checkpoint. All right, go ahead and work on these on your own problems. Pause your video and ready to check your answer. Resume. Here's what you should have got. Make sure you answer that EQ. I hope you're having a great day. See you later, guys.